Good afternoon, class. We are looking at pre-calculus practice test number 5, module 5, covering chapters 9, 10, 11, chapter 9, systems of linear and nonlinear equations, chapter 10, analytic geometry, chapter 11, sequences and series, and we are looking at chapter 9, systems of linear and nonlinear equations. If the system of linear equations results in two parallel lines, the system is it's an inconsistent system. The system has no solution. The graphs are parallel lines. They have the same slope, but different y-intercepts. We can see the two lines have equal slopes. M1 equals M2, but B1 is not equal to B2, different y-intercepts. If we solve them, we end up with a contradiction such as 0 equals 7. If the system of linear equation results in two intersecting lines, the system is a consistent system with independent equations. The system has a single solution. At the point of intersection, the graphs are simply different. They have different slopes. So two lines with different slopes. M1 is not equal to M2. And finally, if the system of linear equations results in a single line, you have a system which is a consistent system with dependent equations. The system has an infinite number of solutions. The graphs are identical. They have the same slope and the same y-intercept, which means if we solve them for the y, we end up with exactly the same solution. M1 equals M2, B1 equals M2. And if we go by solving it, let's say by substitution, or elimination, we end up with a true statement such as 0 equals 0. We want to solve this system. One easy way, if we multiply the top by number 5, we get minus 5x plus 10y equals negative 5. And if we just don't touch this, we notice these two cancel each other, these two cancel each other, but these two add up to positive 1, which is a false statement, which means no solutions, and we must have had two lines that were parallel. In this case, if I want to solve, if I want to eliminate x, I can multiply this one by 5, this one by 2. If I want to eliminate y, I can multiply this one by 3, this one by 7. Let's do that. And when we multiply this one by 3, we get 6x minus 21y equals 9. When we multiply the second one by number 7, we get minus 35x plus 21y equals 49. Let's do that. And these two cancel each other. These two add up to negative 29x, 58. We divide by negative 29, x becomes negative 2. We use one of the original equations. For example, the first one. 2x minus 7y equals 3. So if we use that, we replace the x with negative 2. This becomes minus 4. We move it to the other side, becomes positive 4. And y becomes negative 1. And it's really a good practice to always check. We use the first equation to come up with the second variable. We use the second equation to check. So you have to check with the second equation. Minus 5 times minus 2 is positive 10. 3 times negative 1 is negative 3. Do they add up to 7? The answer is yes, so it works. Matrices, a rectangular array or table of numbers. A matrix with m rows and n columns has dimension m by n. So m rows, n columns. First, we mention the number of rows, second, the number of columns. A square matrix has the same number of rows and as columns. The dimension of a square matrix is n by n. We can add matrices with the same dimensions only. For example, this is 2 by 2, this is 2 by 2. So you add 5 and negative 4. That gives you positive 1. You add negative 6 and positive 6, that gives you 0. You add 8 and 8 gives you 16. You add number 9 and negative 3, and that gives you positive 6. That's how you add them up. However, the product is a different story. The way the product works, so the product of AB, first and foremost, of an M by N matrix A and an N by K matrix B is M by K. In other words, the number of columns of the first one must be the same as the number of rows of the second one. So we have 1, 2, 3 columns for the first one, 1, 2, 3 rows for the second one. That's how it works. Then you pick the number of rows from the first one, number of columns from the second one becomes M by K. So for the sake of argument, as far as the size goes, we can see that this is a 2 by 3, it's a 3 by 2, and the result must be a 2 by 2. I highly recommend, if you're multiplying, start with the dimensions. So now we are going to multiply this row by this column and add them up. So minus 3 times minus 6. Let me write that. Minus 3 times minus 6 plus 4 times 2 plus 2 times 3, and they add up to 32. I want to make sure we understand what's happening here. Minus 3 times minus 6 plus 4 times 2 plus 2 times 3. So that would be the first entry. Now this one by this one would be the second entry. So if we wanted to multiply this, minus 3 by 4, let me write that. So minus 3 times 4 plus 4 times 3 plus 2 times negative 2. That gives you negative 4 again, just to show you. Minus 3 times 4, 4 times 3, 2 times minus 2, we add them up. So we have 32 here, minus 4 here. And if you multiply this one by this one, you get the third entry. This one by this one, you get the last entry. This is how you do the multiplication. 32 minus 4 minus 18, 12. For example, if you want to figure this out, 5 times minus 6 is minus 30, 0 and 2, that goes away 0. 4 times 3 is 12. They add up to negative 18. The last one, 5 times 4, 0 times 3, 4 times negative 2, they add up to 12. That's how you do the multiplication. Let me erase so I can read this for you. Matrix methods to solve systems of linear equations. We can do REF, short for row echelon form or row echelon method. Apply row transformation to get ones along the diagonal. It's known as a leading coefficient. Leading coefficient is 1. And zeros below. So this is 1, all of them 0. 1, all of them 0. 1, all of them 0. And as far as the augmented matrix is concerned. Or REF, reduced row echelon form or method. Apply row transformation to get ones along the main diagonal will be 1 and zeros both below and above the augmented matrix. Every leading one is to the right of the one above it, and any non-zero rows are always above rows with all zeros. Let's solve this system. Well, if we want to solve the same system that we just did, but now using augmented matrix. So the way we write the augmented matrix, -1 and 5, we just write the coefficients. That's the first column, 2 and -10. This is the coefficient matrix, and the solution matrix -1 and 6. So look at the augmented matrix, -1 and 5, 2 and -10. I like to write them column-wise, it's easier. -1 or 6. If you want to go row-wise, -1, 2, -1, -1, 2, -1. 5, -10, 6, 5, -10, 6. And so it can be done by hand. First of all, this is called the coefficient matrix, as far as the terminology is concerned. And so this is the solution matrix. They also have X and Y, the variable matrix, if you will. So the idea is that to make this to 1. So one easy way to multiply the whole row by the same number, in this case, by -1. Remember, if you're multiplying this row by a number, that means you're multiplying this equation by a number. And you can do that by any number except 0. So the row transformation is everything that we can do to equation. So the way we write it is -R1 goes to R1. So this becomes 1, this becomes -2, this becomes +1, and the second row remains intact. So we wanted to get 1, we achieved that. The next one is you go down, however many that you have only 1 entry, but if you have even 10 entries, each and every one of them, we want to change it to 0. So, and we want to try to avoid fractions because it makes it very difficult sometimes to deal with it. So if I multiply this one by 5 and subtract it from this, I get 0. So -5 R1 plus R2 goes to R2. So if I multiply this by 5 and subtract it from this, I get 0. If I multiply this by 5, -10 and subtract it from -10, I get 0. If I multiply this one by 5 and subtract it from 6, I get 1. So what does that mean? If we look at the final row, every entry is 0, except the last one. If all of them are zeros, it's an identity. But if only all of them are 0 except the last entry, then there is no solution. It's an inconsistent system. As far as a calculator is concerned, this is how we use a TI calculator. And we can do row echelon form. So you put the matrix in. If you put REF, gives you the bottom. And that is the same thing. By the way, this may or may not be the same as this one because row echelon form is not unique. But what I want to show you quickly is it's how to do it with a calculator. So the idea is, it says how to enter matrix. So matrix enter found by pressing second and x to the power of -1. So second and x to the power of -1. And look, we have the names A, B, C, D, we have the math, we have the edit. So you go to the right and you click edit. Now it's editing the first one and that's good enough. Let's work on the first one. The very first thing is we want the dimensions, and the dimensions, we have 2 rows and we have 1, 2, 3 columns. So that's the first thing. Now I'm going to input the numbers that I have here. See, this is my augmented matrix. So I'm going to put -1 for the first entry. Enter. The second one is 2. The last one on the first row is -1. Then I have 5, -10, 6. So this is my matrix, as you can see it here and here. Now I'm going to do REF. So now how to solve a system row in a row echelon form. So we entered the matrix per instruction here for TI calculator. So matrix editor by verse. So we're going to do the same thing, second x minus 1. And then we go, matrix is defined by that. And then we go to math, which is the second one up there. So we click on, we go to the right. Okay. And then we bring the arrow down until we hit REF. So if I click on that, second, matrix A. Let's quickly try it again. Let's bring it to REF. And second, get to matrix. And we want matrix A, just press enter. And if you press enter again, notice what it gives you. The same thing that we got here, 1 minus 2, 1.2. What matters is the last row. All of them are zeros, except the last entry. And that gives us the same answer that was mentioned here. The final row indicates that the system is inconsistent and has solution set, which is an empty set. This is phi standing for an empty set, everybody. So let's do 2b. So we want to write the augmented matrix for this. So 2 minus 5 minus 7, 3, 3, 7. Or if you want to go row wise, 2 minus 7, 3, minus 5, 3, 7. And now, if we were to do it by hand, definitely it takes some time, but you should be able to do that. For example, I want to get a 1 here. I can divide the first row by 1, but if I want to avoid dealing with fractions, I can say, for example, if I multiply this one by 3 becomes 6, and I add this one to it becomes 1. So 3R1 plus R2 goes to R1. So if I'm going to multiply this one by 3 and add this row. So 3 times 2, 6, and negative 5 is positive 1. 3 times negative 7, negative 21, and 3 is negative 18. 3 times 3, 9, and 7 is 16. That's how we arrive at those. So now that we have that, remember what we want to do according to REF, we want this one to be 0. So let's write the first one, which we don't want to change. What we want to change is we want to make sure this becomes 0. So if I want to make this one 0, if I multiply this one by 5 and add to it, this becomes 0. So I'm going to write 5R1 plus R2 is a new R2, goes to R2. So 5 times 1 and negative 5 gives me 0 here. 5 times negative 18 plus 3 gives me minus 87 here. And 5 times 16 plus 7 gives me positive 87. So I was looking for 0, I found it. The next thing is that I want to make this one 1. So I'm going to divide by negative 87 the whole row, the whole equation in essence. So if I divide everything by negative 87, 0 by any number, by negative 87, when you divide it 0, this becomes positive 1, this becomes negative 1. And what matters is to understand the meaning of this. If I were to rewrite this going back to the system, this means 1x, or simply x, minus 18y equals 16. This means 0x plus 1y equals negative 1. And the idea is that this gives you the answer y equals negative 1, everybody. This means y equals negative 1. Back substitution. Replace this with negative 1. So y equals negative 1, right? So if you put negative 1 here, you get positive 18. Subtract it from 16, you get negative 2. So those are the answers. And I can do the matrix transformation. If I go with the REF, row echelon form, I get 0, 1, negative 1. So I have this answer. Of course, this is slightly different and it doesn't matter. However, if I go with REF, this portion is an identity matrix, everybody, by the way. This is an identity matrix. Now, what is an identity matrix? Matrix is a square matrix which the main diagonal is 1, everything else is 0. So now 0x plus 1y equals -1. That means y equals -1. This means 1x plus 0y is -2. So that means x equals -2. So pretty much the last column is the answer. This is your answer. X is -2, y equals -1. So REF will give you the answer in one shot. Let's go to this question. 3x minus 4y plus 2z equals -15. 2x plus 4y plus z is 16. 2x plus 3y plus 5z equals 20. We can do it by hand, and of course, then we discuss it with matrices as well. First, let's throw in equations 1, 2, 3 because it makes it easier. Then we notice right away that if we look at what is given to us here, by the way, you decide whether you want to get rid of the x or y or z, and it seems to me it's easier to get rid of the y because right away just equations 1 and 2, just equations 1 and 2. If you add these two up, these two cancel each other. Equations 1 and 2, these two cancel each other. 5x plus 3z equals 1. So what is the idea? The idea is that you have 3 variables to begin with, x, y, z. Now you want to go to 2 variables. Since we have x and z, that means we want to go to x and z in the third case also. Equation number 3 hasn't been used yet. It must be used with either the first or the second equation. It doesn't matter which one. So this is a must and one of those two. And we get rid of the same variable, namely y. So for example, if we use the first one and we multiply this one, notice this is -4y, this is +3y. If I multiply this one by 3 and this one by 4, we can get rid of it. So let's multiply this one by 4 and this one by 3. And we get the following equations. This becomes 9x minus 12y plus 6 equals -45. This times 4 becomes 8x plus 12y plus 20z equals 80. Obviously, these two cancel each other. Can add these two to 17x, 26z, number 35. So we're going to call it equation number 5. Now, equation number 4, equation number 5, both of them involve x and z. So we went from a system of 3 variables to a system of 2 variables. Now we work with these two. And again, you decide whether you want to get rid of the x or z. If you want to get rid of the x, you can multiply this one by 17, this one by 5. One of them negative, doesn't matter which one. So if we multiply this one by 17, we get 85x plus 51z equals 17. And this one by -5, we get -85x minus 130z minus 175. These two cancel each other again. And then when we add these two, we get -79z. When we add these two, we get -158. If we divide by -79, we get +2. So z is +2. You have to go back either to equation 4 or equation 5 to find x. So for example, equation 4, 5 times x plus 3 times 2 equals 1. And this is 6 minus 5 divided by 5, and x becomes -1. Now we have to go to one of the original equations, 1 or 2 or 3. For example, if you go to the first one and you replace the x and z, you can find the missing y. So 3 times x, which is -1, minus 4y, which is missing, plus 2 times 2 equals -15. So the whole, these two add up to 1 and go to the other side becomes negative 16 divided by negative 4, y becomes 4. And I like to put that in order so it becomes clear that x is negative 1, y is 4, and z equals 2. Needless to say, we use the equation 1 to come up with the answer. We must check with equation 2 as well as equation 3. That's the beauty of math. You can check your work. Let's look at the matrices. If I go to, and I put it in matrix P in this case, and I said 3 by 4, okay, because of this fourth column, okay. So I have 3, 2, 2, negative 4, 4, 3, 2, 1, 5. That doesn't have enough room to show you. But when we go to the right, it shows minus 15, 16, and 20. So this is the last column that should really fit here in essence. So this is the augmented matrix. Now we can do REF, we can do REF, row echelon form and reduced row echelon form. Let's look at both cases. If we do REF, and again, it doesn't have enough room to show you, but the first column, notice the first entry is 1, everything underneath is 0. When you go to the second column, this leading coefficient must be 1, underneath is 0, the top doesn't matter. And when you go to the third column, again, this is 1. And so right away, this tells you, and again, you can change that, by the way, to a fraction. You can change the answer to fraction. So you can see the whole, after REF, row echelon form, has been performed, this augmented matrix changes to this matrix. 1, 2, that means this last entry is V equals 2. This means Z equals 2. Then you do back substitution, you come up with the answer. However, if we do REF, notice this again is the identity matrix of 3 by 3. And so this means Z is 2, this means Y is 4, this means X is minus 1. So for example, this one is 1X plus 0Y plus 0Z equals negative 1. 0X plus 1Y plus 0Z equals 4. 0X plus 0Y plus 1Z equals 2. So EF in one shot gives you the answer, as we have it here. We want to solve this system. We notice if we multiply this one by 8 and we keep this intact, in other words, we look at the equations 2 and 3 only, so let's multiply this by 8. We get 16y plus 24z equals negative 112. And if we add them up, we get 0 on the left side. They cancel each other. But over here, we get some number. It doesn't matter what it's, negative 224. But the fact of the matter is 0 is not equal to negative 224, which makes it a false statement. Therefore, there is no solution. For this system, I'm going to multiply this one by 3, okay? Because I notice if I multiply this one by 3, I can get rid of the x, for example. So when I multiply by 3, I get minus 3x minus 9y equals negative 6. And now, if I add up both sides, everything cancels out. 0 equals 0, which is a true statement. And therefore, we have an identity. It's an infinitely many solutions. Normally, when that happens, they like to solve for y. So if x is x, what is y? One easy way, if you solve for y here and you write it here, then all you have to do, choose x, and over here we replace it again. A quick way to show that, if you look at this equation, you get minus 3y equals minus 2 plus x. And if I'm going to divide both sides by -3, I get this answer, which gives me x comma -1/3 x plus 2/3. Now, if I was going to use the augmented matrix of -1, -3, -2 here in the row, 3, 9, 6 in this row, and I do REF, I end up with the zeros at the bottom, which means exactly the same thing, infinitely many solutions. Now we are dealing with a nonlinear system. So far, we've done a system of equations dealing with linear. Now they are nonlinear. But methodology is very simple. We can add them up. We can clearly see if we add up, these two cancel each other. We end up with 4x squared equals 28. If I divide both sides by 4, x squared becomes 7. X becomes plus minus square root of 7. So x has two answers. If you use one of those equations, it's easier to use equation number 2. You get x to the second power. And because it's to the second power, I put a plus or minus, makes no difference. So I'm going to put plus minus. Plus y squared is 16. This is 7. If I subtract from both sides, y squared is 9, y is plus minus square root of 3. It is important to notice you have two answers for x, two answers for y. When you put them together, it means 4 answers as follows. Minus square root of 7 with -3, minus square root of 7 with +3. Now, plus square root of 7 with -3, plus square root of 7 with +3. And you should always check. We know that it works with this one because we used equation 2, but check it with equation number 1. All you have to do, pick one of them and put it in there. For example, if we check this one here, we get 3 times minus square root of 7 minus -3 squared, and the question is it equal to 12? This is 7, so 3 times that is 21. This is -9, and it checks. So you should check your work always. You should check with the others, they work out the same. Here's the system of inequalities we want to graph. First and foremost, we just look at each case and change it to equality, which becomes a line. So every line, all you have to do, pick up a couple of pairs to graph them. Okay. So that's exactly what we are going to do. In this case, if x is 0, y is -2. If y is 0, x is 1. So we have the pairs here. In this case, if x is 0, y is 3. If y is 0, x is 2. We have those 2. We're going to plot those two pairs, and come up with the two lines. So as you can see here, 0, -2, and 1, 0 is the red line, 0, 3, and 2, 0 is the blue line. And when we go back to look at this, this is inequality. This has the equality, which means a solid line, but this one is a dashed line. So the very first thing, we write the equations, not to get confused which line is which. And then this is a dashed line. Now there are 1, 2, 3, 4 regions. One of them is the solution. So you pick a test point such as 0, 0, because 0, 0 doesn't belong to any of them. It makes it easy. And that would be the point that you check for this line, check for this line. So for this one, if I put 0, 0, and x is 0, y is 0, 0 less than 2 is a true statement. For this one, therefore, there, remember originally this was the red one, 0, 0 works. So this is the side that works. For this one, if you plug in 0, 0 larger than or equal to 6, it's a false statement. So That is true, this is false. So for this one, this doesn't work, so it's the other side. And so when we put them together, you get this one, or just do this. For this line, you put this in red. For this line, you put this in blue, and they come together here. So this region is the answer to both. We do something similar to that. We graph the equality of y equals x squared plus 1. As you know, y equals x squared is a parabola. X squared plus 1 shifts up by 1. So this is the graph. And all you have to do, pick up a test point somewhere inside, somewhere outside. You can pick 0, 0. You can pick 0, 2, but clearly not on the graph. By the way, because this has the equality, you have to go with a dashed curve. The curve itself is not part of the solution. So for example, if you plug in, if you use the test point 0, 2, so if you replace the x with 0 and y with 2, 2 is larger than 0 plus 1. Yes, that's a true statement. So that's a true statement. So this works. Everything inside works. And you can shade it like that. Or you can put 0, 0, and you see that 0 is larger than 1. It's a false statement. That doesn't work. If you plug in 0, 0, so it's the opposite. So it's outside, that doesn't work. All right, let's look at an application. A chemistry lab assistant wants to prepare 10 liters of 48% acid solution. In stock, we have 80% and 40% acid solution. How many liters of each in stock solution should he mix to prepare a 10-liter mixture? This is a class of problem known as a mixture problem class. So we come up with a table. We have 80% solution, 40% solution. We are going to mix them. And so you can stick with 80% or change it to 0.8. You can leave it as 40% or 0.4. And we want the mixture to be 0.48. Now, how much of each we have? No idea. How about X amount of that? By the way, we have a total of 10 liters. And that's the concept of a mixture problem. This is fixed. So X amount here, Y amount there. And so that creates an equation, X plus Y equals 10. Also, the pure amount, the actual amount of acid is the product of the two. Something which is 80% solution, that means 80% acid, the rest is water. So 0.8 times X goes here. 0.4 times Y goes here. And 0.48 times 10 or 4.8 goes here. And this is the second equation. So this one gives us the first equation. This one, 0.8x plus 0.4y equals 0.48 times 10, which is 4.8 is the last one. Now, we can do by any method. Substitution is a good practice. This one, y is 10 minus x, and we are going to replace the y with 10 minus x. When we distribute, this becomes 0.4 times 10 or 4. This becomes minus 0.4x, and we can see that these two add up to 0.4x. Subtract the 4, we get 0.8. And when we divide by 0.4, x becomes 2. So we have 2 liters of 80%. The rest of them, 8 liters of 40% solution. And by the way, this clearly I'm using the first equation, but you really have to check with the second equation to be on the safe side. How many liters of a solution that contains 15% chemicals must be mixed with the 6 liter of solution containing 10% chemicals to make 10 liters of solution containing 12% chemicals? So let's make up the table again. And again, 15%, 10%, and the mixture. You can leave it, and even you put the mixture as 12%. You can keep it as a percent, or change them to 0.15 and this one is of course 0.1. This one is 0.12. Now 0.15. How many liters of a solution of a 15% chemical must be mixed with 6 liters of solution? So this is 6 liters. 6 liters of 10%. 10% or 0.1. To get 12%, 0.12. Now, how much of this we have no idea. How about X amount? They must add up. So this would be the sum of these two numbers. That's the concept of a mixture problem. So X plus 6. And therefore, the last column, the pure amount of chemicals, is 0.15 times X here, 0.1 times 6 here, and 0.12 times X plus 6 at the bottom. And again, this last column, they must add up. This plus this must be equal to that. And again, it's very easy to come up with this equation when we have this setup and this table. Without the table, it makes it almost impossible to do so. So all we have to do is distribute. So this one becomes 0.12x. This becomes a 0.72. And by the way, you can multiply by 100. And if you want to do that, let me just quickly show you. If you want to multiply both sides by 100 to get rid of the decimals, this becomes 15. This becomes 10 times 6. This becomes 12 times X plus 6. It's up to you, and it makes no difference. Now, we are going to move this and subtract it on the left side. And I move this. We end up with 0.03x equals 0.12. Divide both sides by 0.3. I can change this to 3. That means the top is 12. In other words, I'm multiplying the top and the bottom by 100. X equals 4. So we need 4 liters of 15% solution. A plane can travel 800 miles per hour with the wind and 720 miles per hour against it. Find the speed of the wind and the speed of the plane in still air. As you know, when we go with the in the same direction as the air or even current, their speed will help us, will be added to our speed. If we go against them, they work against us. So 800 miles with the wind, and I'm going to call them, instead of X and Y, I'm going to call them P and W. P stands for the speed of the plane, W for the wind. So P plus W is 800, P minus W is 720. And clearly, all you have to do, add them up. These two cancel each other. You end up with 2P equals 1520. So these two cancel each other. Divide by 2. P becomes 760 miles per hour. And if you put it into any of those equations, the first one, P with what number? 760 with what number is 840 miles per hour, or the second one. And by the way, as always, check to be on the safe side. Admission tickets to the Braden River Little League All-Star Game cost $4 for adults and $1.50 for children. A total of 225 tickets were sold, and a total of $500 was collected from ticket sales. How many adult tickets and how many children tickets were sold? Let's set it up as follows. Adults, children, total tickets cost, number, total amount, so on and so forth. So the very first thing is that $4 for adults. In front of the adults, we're going to put $4. And it's going to cost $1.50 for children. Let's put it there. Now, total of 225 tickets. So number of tickets is here, total is here, 225. And we are going to collect a total of $500. The total amount, $500 here. Now, how many of each we don't know? I can go with X and Y, or A for adults, C for the children. I think it makes it easier that way. Clearly, this is one equation, A plus C is 225. Now, how much do we collect? From the adults, 4 times A. From the children, $1.50 times C. And these two must add up to 500, which is the second equation. And you can do it by any method. If you want to do it by, let's say, elimination here, if I multiply this one by -4, I can get rid of the A. So that gives me -4A, -4C, minus 900. So I just add equation number 2. These two cancel each other. And these two cancel each other. These two give us negative 2.5C. These two, they give us negative 400. And it gives us 160 subtracted from 225, and we get 65. So we have 160 children, 65 adults, and we must check it with the second equation. One leg of a right triangle is 4 centimeters less than the other leg. The area of the triangle is 70 square centimeters. Determine the length of each leg. Well, let's do the drawing. This is X, this is Y. And we know the area is 1/2 base times the height. So this is right. Because it's a right triangle, the sides, one of them is the leg, the two legs, one of them is the height, one of them is the base, because it makes a 90-degree angle. So one side is 4 centimeters less than the other. So X seems to be smaller in this. So X is Y minus 4. And then half of X times Y is 70. So X minus Y is 4. X equals Y minus 4. And half of X times Y is 70. Because we want to avoid dealing with fractions. If we multiply this one by 2, we get XY equals 140. And now X is Y minus 4, replace it. Substitution will do the job. Now this one is Y squared minus 4Y, and we're going to move the 140. So Y squared minus 4Y minus 140 is 0. When we do the factoring, Y minus 14, Y plus 10 equal to 0. This gives us positive 14. This gives us negative 10. Sides, dimensions can't be negative. So the answer is Y equals 14. So if Y is 14, X becomes 10. And we can quickly see that if you multiply these two, 140 times 1/2, you get 70. In other words, you can easily check with the second equation, and you must. The sum of three numbers is 105. The third is 11 less than 10 times the second. Twice the first is 7 more than 3 times the second. We want to find the numbers. So first we want to define the variables. We're going to say X, Y, Z. X is the first, Y is the second, Z is the third. It is extremely important that you write which number is the first one, second one, third one for yourself so you don't get confused. So the very first equation, X plus Y plus Z equals 105. The first equation, the blue line. The second equation, the third Z is equal to 11 less than 10 times the second, 10Y minus 11. So please read the second. The second equation comes from the red piece. The third, that means Z, is equal to 11 less than 10 times the second. The second is Y. Finally, twice the first, that means 2X, is 7 more, 7 plus 3 times the second, 3Y. So I hope you see how we arrive at the equations. The rest should be fairly simple. You can use any method, including matrices, to come up with the answer. But for now, let's see what we want to do. So the equation yx plus y plus z is 105. And I noticed the last one has x and y. The first one has everything, and this one has z and y. So I can replace the z with 10y minus 11. If I replace the z with, this is equation 1, equation 2, equation 3 again. So in equation 1, I'm going to replace the z with 10y minus 11. So I'm going to replace the z with this. And so I get x plus 11y equals 160. I'm going to call it equation number 4. Equation 1, 2, 3, and now I'm going to call this equation number 4. Equation number 4 and equation number 3, I can put them next to each other. Now, there are a couple of different ways of solving it. Here's an interesting method. I notice this is 2x, so let's multiply this one by 2. So I get 2x plus 22y equals 232. Now I can replace the 2x instead of, I could have solved for x here, but it would give me a fraction, but this is a faster way. Instead of 2x, I'm going to put 7 plus 3y here. So this will replace the 2x. And so if I add these two, I get 25y. This gives me 25y. I'm going to subtract 7 from both sides. I get 225. So that's what I did, 2x and 7. Okay. And then I'm going to divide by 25. And I get 9. So y is 9. Equation 2 gives me z. 10y minus 11. So 10 times 9 minus 11 makes it 79. X and y and z, that means 9 and 79. And x must add up to 105. And x becomes 17. I like to write them in order. And you can check, I believe, with equation 3, because everything is equation 1 was used, equation 2 was used. Check it with the third equation. Use partial fractions to decompose. So what is partial fraction? We know how to add rational functions. The reverse process is called partial fraction decomposition. Partial fraction decomposition is used when we have a fraction of p over q or p of x over q of x, where p and q are polynomials, and the degree of p is less than the degree of q. Note, if the degree of the numerator is larger than the denominator, then perform long division first. So what happens? The denominator q has distinct linear factors. So we write them in this format. P over q is a sub 1 over a sub 1x plus b1 plus a sub 2 over a sub 2x plus b2 all the way to the end. Here's an example. 3x over x minus 1 times x minus 2. We have factored the denominator a over x minus 2, b over x minus 1, and then we have to go through the process. We find the answer. The second case is that we have a repeated factor, at least in one case. So for example, this one, if x minus 1 squared instead of x minus 1, what do? We put a over x minus 1, b over x minus 1 squared, and then c over x minus 2, and we go through the process of solving it. So we have to write them 2 times, once without the repetition and once with it. So if in case it was to the third power, then we would have another one over x minus 1 to the third power. Now, some irreducible quadratic factors. So for example, it's easier to follow it here. When you factor, this one can't be reduced. It's a This is of degree 1, x minus 1, but this is of degree 2. So the degree 1, again, a over x minus 1. But for the degree 2, we put bx plus c instead of just a number, or x squared plus 1, and you can go through the process to see what happens. Another example is that this x squared plus 1 also has is being repeated. So the first one, again, repeats, the second one repeats, and this one we have to put another bx plus c to find out maybe dx plus e. So the point is you have to be careful with what you are doing. So let's start with the simple example, x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x, and we want to use the decomposition. First, notice the degree of the numerator is less than the degree of the denominator. Otherwise, you have to do the long division. So let's factor the denominator. First, we factor the x out. And then this piece can be also factored. So we get x times 2x minus 1 times x plus 2. My assumption is we have no problem with factoring. So we're going to write this one as a over x plus b over 2x minus 1 plus c over x plus 2. So a over x, b over 2x minus 1, c over x plus 2, because they're all linear. That means degree is 1, and they're not being repeated. Then what do? We are going to get rid of the fraction. We're going to multiply both sides by the LCD, which is x times 2x minus 1 times x plus 1, 2. When we multiply by it, if you multiply both sides by LCD, which is x times 2x minus 1 times x plus 2, what happens is that the left side will lose the denominator. What happens to the right side? This has x, so a times 2x minus 1 times x plus 2, plus b times x plus 2, plus c times x times 2x minus 1. I hope nobody has any problem with that. So again, I repeat, this side, the denominator goes away. This one, a, you multiply by these two. B, you multiply by the other two. And c, you multiply by the other two denominators. Now we are going to multiply, collect like terms. Notice if we multiply these two, we get 2x squared plus 3x minus 2. If we multiply these two, we get x squared plus 2x. If we multiply these two, we get 2x squared minus x. And now, what I want you to pay attention to is just x squared for now. If you pay attention to x squared only, what would be the coefficient of x squared? 2a times x squared, b times x squared, c times 2x squared, meaning we have 2a plus b plus 2c times x squared. You do the same thing for x. And the constant. Speaking of the constant, there's only one constant which results in minus 2a. So we write the left side, and notice what I've done on the left. I put x squared as 1x squared in essence, 2x and then minus 1. So see what happens. So you write them in this fashion, 2a plus b plus 2c times x squared plus 3a plus 2b minus c times x minus 2a. Now, if the left and right are equal, then x squared must have the same coefficients. Therefore, if you look at the coefficient of x squared here, must be 1. If you look at the coefficient of x, must be 2. And if you look at the coefficient of the constant, must be negative 1. Therefore, you have a system, a plus 2c is 1, 3a plus 2b minus c is positive 2, and minus 2a equals minus 1. This is the system you want to solve, and it's very easy to solve. First and foremost, you can see that a is positive 1/2. Then you replace the a with positive 1/2, and you have a system with two variables. I'm assuming everybody can solve it. B becomes 1/5, C becomes negative 1/10. You go back to this one, replace the a with 1/2, B with 1/5, C with negative 1/10. You're done. Let's look at the case where we're going to factor the denominator, and that becomes x times x squared plus 4, which is irreducible quadratic factor. X cubed plus 4x is x times x squared plus 4. We're going to write it in this format. So this fraction is a over x, because this is of degree 1. And then bx plus c over x squared plus 4, because this is degree 2, we're going to write this as degree 1. Again, we're going to do this. We're going to multiply by LCD, which is x times x squared plus 4. And so the first fraction on the left, this goes away. And the last one becomes a times x squared plus 4, and then bx plus c times x. Now, if we concentrate on x squared, and to do that, this is b x squared plus cx. So a times x squared, bx squared. So a plus b times x squared, x only c, and then 4a. Okay. Now, x squared has a coefficient of 2, so a plus b must be 2. X has a coefficient of negative 1, cx, c must be negative 1. The constant is 4, 4a must be 4. So pay attention to this. A plus b must be 2. C must be negative 1. 4a must be 4. Obviously, c is negative 1. It's just given to you. 4a equals 4. That means a equals 1. So c equals negative 1 is given. This one you divide by 4. Gives you a. A is 1. You put it here. If a is 1, b must be 1 as well. And so we go to this one. We replace the a with 1, b with 1, and c with negative 1. So 2x squared minus x plus 4 over x times x squared plus 4 becomes 1 over x plus x minus 1 over x squared plus 4.